We just want to start you off by showing you how you can use the DESMOS graphing calculator and the calculator for the scientific calculator for calculations. First, I'm going to start you off with the graphing. So you're going to go to desmos.com. You're going to get to this screen and you're going to hit Start Graphing. All right, when you get into Start Graphing, the coordinate plane is in halves. Each unit box is a half unit, so we want to zoom out in a little bit so that we can get this to be 1 unit. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, because that's all we're going to need, and we don't want it to change from a typical graph paper. So what we're going to do is I'm going to show you how to check your work that you are doing using the DESMOS calculator. And first we're going to do the vertex form that we did in our lesson, and we're going to put in -1 divided by 2. You can use the slash button just above next to the shift button on the right hand side. Arrow to the right, open parens, and x plus 3, and close your parens. And then you're going to use the caret button, which is above the 6. So you have to use shift 6, and that will give you the little caret, which will raise it to a power. Right arrow down so that off of there so that you're out of the power, and then plus 4. And there is our first graph that we did in our lesson, which again, vertex form you guys are very familiar with and have been doing quite well prior to us going to home learning. What I want you to notice is that you're going to see the vertex, and you're going to see 2 points that are on the x axis. Those are x-intercepts. We haven't gotten there yet for defining what they are or identifying what they are. However, you will see them graphed because that is how the calculator works. Don't sweat that. I don't want you to look at that and go, I didn't get those numbers, because it's okay. You don't have to get those numbers. What we want to do is, like always, we know that this parabola is going downward because of the negative sign here, and it's going half the rate of the parent. So the parent moves out 1 from the vertex, it gets squared, and goes down 1 in this case. And it doesn't, because here we're going half that amount. So we'd go out and half, and we'd go out 2. Typically the parent would go 4, because 2 squared is 4, but here we're going half that amount, so 1, 2. And that's all you need. You just need those points. When you do this, don't worry about these points that you're seeing on the x-axis. Worry about what your graph looks like on paper compared to this, because you're using this to check your work. All right, let's go to the second problem we did in our lesson, and that is in standard form. So let's go back, just delete everything, and our standard form equation was x squared, so x caret button 2, so again, shift 6, 2. Come to the arrow off the right of that and say plus 2x, and then it was minus 2, and that was our standard equation. And that is, got a vertex at a -1, -3. And it has the same shape as the parent because the coefficient in front of x squared is 1. And when we move 1 to the right or left, we go square that and go up 1. We go 2 to the right or left, we square it and go up 4. And those are the points that you're looking for that you should graph on your paper form. And then you want to check it to be here, same as this. So this will give you an indication that you are correct. Please don't use it to copy, because it won't help you to retain the knowledge that you need to have to learn this and to be able to do this without having a calculator at your disposal. Okay. All right, let's check the other one that we did in class, because we did 4 examples. All right, this one was -2x squared. Sorry, I forgot the -2, so I'm going to just insert that there. Plus 12x, and then minus 10. And what we found when we did our work, we had a vertex at 3, 8. This is going twice as fast as the parent in a downward direction. So when the parent goes 1, and it would then go squared and go down 1, we're going 1 out, and we're squaring it going twice the amount of the parent, so go down 2. When we go 2, the parent would then go down 4, but we're going twice, so we're going 8. So 1, 2, 3, 4, 5, 6, 7, 8. This happens to actually be the same as the x-intercepts, which is nice. So you'll see them, but that won't always be the case, as I've already explained. And the last problem we did, okay, we've actually are very good at graphing this one because we've been doing this very well prior to the home learning. Okay, it's -1 half x squared, -1 divided by 2. Arrow off and get that x into that neutral position. Don't let it stay in the denominator. Raise it to a power of 2. Okay, and there you go. And its vertex is at 0, 0. Okay, and then we move out 1, and we go half the distance of the parent, so half. We go out 2. Instead of going 4, we go half the distance, we go 2. Now you only need 5 points to graph. If you go out 3, we normally would go 9, we'd go 4.5, 2, 3, 4.5, and you do that to your best estimate, all right? We want 5 points, as always, to make a pretty nice looking parabola. Make sure that they're not, straight lines, that they are curvy, and make them to the best of your ability. And you guys and girls will be screenshotting or scanning those in for me, or taking a picture of it and setting it up and scanning it into me on course messaging, and I will get your work in, and I think we should be good from there. If I have other directions on where to Dropbox it or whatever, I will let you know. All right, so this will help you check. Now, the other thing you can do, which is calculating, which some of us, particularly with fractions, have a little trouble with, and we want to make sure that they don't trip us up and give us the wrong vertex. So obviously our first problem was in vertex form, so we know it was the opposite of what we saw inside and exactly out, so negative 3, 4. But this next one in standard form, which is what our lesson is primarily about, can be a little tricky. So scientific notation calculator, so click on scientific, and it brings you to the calculator that you should be familiar with. All right, and what we found here was that our vertex was the opposite of B over 2A, so it came out to be negative 1. So look back at the notes that we took and from the previous video on the second problem. And so if our x value of our vertex was negative 1, then we're going to plug that into f of x. So we're going to put negative 1, and we're going to raise it to the power of 2, because that was our equation, x squared plus 2x minus 2. And I can't write that out on the screen here, so you'll have to follow the other notes. Then you're going to arrow off this power, put plus 2, and in parens negative 1, and then you're going to do minus 2. And your answer will be here. And as you can see, your vertex was negative 1, negative 3 for that second problem. All right, so this is how you can calculate with any of your problems in standard form. You would literally write it out just like this, putting in the value for x into the x position, and you don't have to do any piecemeal calculating. All right, so you can do it all in one string and put that in with the proper signs, powers, and parentheses. All right, I hope this helps you with calculating. Again, any questions you have, you can certainly on-course message me. I am on, and I will be checking that, as I do through the day. Okay, good luck.